So I want to start with probability, because probability, not only actual probability, it's probability, percentages, and fractions. The three of them are the same rule. One rule for all three. So if I want the probability of something, or I want the percentage of something, or the fraction of something, they're all the same thing. And the rule is just the wanted over the total. So whenever I read in a question that they're asking me to find a probability, I'll just write the rule wanted over total. And then I'll ask myself, what's the wanted? For example, if they want the probability of selecting a boy, then the number of boys would be the wanted over the total, which are all the boys and girls available in a class. The only difference between the probability and the percentages and the fractions is that the percentages, after we already do the wanted over total, we then multiply by 100. So just to give an example, if I have a basket that has red balls, blue and green balls, and I have 2 red, 3 blue, and 7 green, and I say, what's the probability of selecting a blue ball at random? It becomes wanted over total, and the wanted is blue, therefore it's 3, over the total, which is the addition of all these 3, which is a total of 2 plus 3 plus 7, which is 13. So 3 over 13, this is the probability of selecting a blue color. On the other hand, at the same time, the fraction of blue in this basket is the same thing, 3 over 13. If I needed to say what percentage is the blue, I'll say 3 over 13, but then multiply that by 100. Any questions about any of those?
No, Mr.
Awesome. Now let's move to the areas and volumes and so on. The reason why I like the areas and volumes is that for all shapes, they're all the same. So the area of any shape whatsoever is just one rule. And the rule is mainly base times height. This is the rule of finding the area of anything. So what's the difference between this rule that I just explained and all the other rules that we've ever heard? It's just the names. So if you look at a rectangle, for example, a rectangle has a long side and a short side. The long side, we call it length, and the short side, we call it width. So if you look at it, where's the base of this shape? It's apparently this side. And where's the height of this shape? It's clearly this side, because the base and the height must be perpendicular on each other. So if I needed to do base times height, it's exactly the same as doing length times width. It's just that we call it here length and width because that's a rectangle. Same thing would happen in a square, for example. The square has all its sides equal to each other. So we don't call them anything except just side. This is called the side and this is called the side. So if I need the area, it's mainly side times side, which is base times height, which is side squared. We'll then stop at a triangle, and I'll tell you the area of the triangle, which is half times base times height. And I now want to ask you, why is it half times base times height? Why is it that this rule is the only rule that doesn't fit all other shapes? Because I said area of all shapes is base times height. Why is it that the triangle is half times base times height? Anyone?
Because it's the half of a square or
It's a half of a square, yes. So if a square is base times height, a triangle is half the square, so it's half times base times height. So it makes sense why the triangle would have such a weird rule compared to the rest. We then stop at the circle. The circle has its own area, rule for the area, and it has its own rule for the circumference of the circle. Now, what is the circumference of the circle? The circumference of the circle is the line that is actually all around this line right here, the length of this line is the circumference. So if you kind of pulled it apart and spread it to a line, the length of this line is the circumference. While the area is the region inside, is the space inside. So the area of a circle is pi r to the power of 2, while the circumference of a circle is 2 times pi times the r. So I got the area and I got the circumference and I got everything I need. Does that so far make sense? Because I can't move unless it does.
Yes, mister.
Okay, everyone else we're good? Because Amina, are you good?
Yes, mister.
You're sure, sir?
Yes.
Okay, awesome. Mehmet, are you?
Yes, yes.
Because sometimes بس feeling you specifically would not understand and would not say except later maybe. I wanted بس to confirm. طيب, the next thing is mainly the volume. Because the volume is exactly like the area, so it's good to start out to explain it as well. The volume of any shape whatsoever is actually area of base multiplied by the height. So why is that? The volume is of shapes that are 3D shapes, while the areas are shapes of 2D shapes. So when we were talking about these shapes, the area of the base was just a line, and the height was just a line. While if we're talking about shapes that has volumes, 3D shape, the base of the shape is not a line at all. The base of the shape is clearly a shape, is a circle, if this is a cylinder, for example. Or if we're talking about a rectangular block, then the base of that shape is not a line, it's an entire shape, which is a rectangle. Same thing if we're talking about a cube, which has all its sides equal to each other. And in that case, the volume is, the base is a square. So you would just need to look at the shape first and identify what's the base of it, what is the shape of the base, and get the area of that base. Once you do that, if you multiply it by the height, you just got the area. So for example, in this shape, this is the height of the shape, definitely. In this one, this is the height, or this, or this, or that. In this shape as well, height, or height, or height, they're all equal. So I'll just need to get the area of the base. In this case, area of base, it's a circle, so the area of the base is pi r squared. Multiply that by the height, and you got the volume of the cylinder. Same thing for a rectangular block. The base is a rectangle, so therefore the area of base is length times width. Multiply that by the height, and again, you've got the volume. The area of the base here is side times side, and if I multiply that by the height, which is also a side, that would give you the volume, which is s to the power of 3. Any problems in these types of shapes?
No.
There are also shapes that has peaks. What do I mean by that? I mean, think of a cone, or think of a pyramid with a rectangular base. Things like these has peaks. So how do I find the volumes of those shapes? Exactly like the normal volume, which is the area of the base multiplied by the height. So here the base is pi r squared, and multiply that by the height. The only difference is anything with a peak, we have to also multiply it by 1/3. So if I'm talking again about a cone, if the base of the cone is a circle, then that means that the volume of the whole cone is pi r squared times height, but then multiplied by 1/3. Same thing would happen in a pyramid with a base of a square, for example. What's the area of the base? It's side squared. Multiply that by the height, which I do not know here, but then multiply that by 1/3. That would get you the volume of such pyramid. Are we clear on this one as well?
Yes.
So the
Yes.
1/3, let me actually somehow write it down here in a good way and say that shapes with peaks to get the volume, it's just like the normal volume, but multiply that by 1/3, which means 1/3 multiplied by area of base multiplied by the height. That is the volume of any shape with a peak. Let me change this stupid V here. V new volume. I hope you understand any of this once you ever take a look back at it. Right. So I think that covers the ideas of the areas and that covers the ideas of the volumes. We should now work on arithmetic and geometric sequences. Now, a sequence is a set of numbers after each other. They follow a specific rate of change somehow. So an arithmetic sequence is a sequence where it's increasing by addition or subtraction. So let's say you have 1 and then 4 and then 7 and then 10 and then 13 and so on. This is a sequence, and the first term in this sequence is extremely important. In any sequence, the first term is always important. So the first term here is 1. Also, what's the difference from one term to the next one? How do I find the difference from one term to the next one?
3.
Yes, how would you calculate it in any other case? 3 is true. How would you calculate it if I needed to calculate it?
Subtract from
Yes, true.
second term the first term.
True. So you just need to do the following. You just need to subtract أي term. Sorry, not the other way around. أي term اعمله minus ال previous term. So if I took مثلا ال 4 هعملها minus اللي قبلها 1. ده يديني ال difference. أو هاخد ال 10 أعملها minus اللي قبلها, which would give me the 3. That would give me the difference. I don't know why did I just turn to Arabic suddenly. Okay, so the 10 minus 7 would get me 3. So just take any term and subtract it minus the previous term. That would give you the difference. So in order to check first whether something is arithmetic or not, you need to make sure that the differences are the same. We need to make sure that it's always plus 3, not مثلا once plus 3 and another time minus 3, or once plus 3 and then plus 2 and so on. So there is a rule that we can use in any arithmetic sequence to find any wanted term, and that rule is this. It says A1, which is the first term, plus the difference multiplied by n minus 1. So if I needed to find any wanted term, whatever I want to find, I just need to put the first term and then add to that the d, which is the difference, and we just agreed that in order to find the difference, we just need to subtract a term minus its previous. And then the n is the wanted, as we just said, but not the wanted term, the wanted position of, the wanted, مش الvalue بتاعت الterm, not the value of the term, it's the position of the term. So for example, if I have this sequence right here and I need to find the 6th term, so I'll then say that A6 is supposed to be equals to A1, which was the first term, which is 1, plus the difference, which is 3, multiply that by n minus 1, which is 6 minus 1, and that would get me the answer as 3 times 15, a total of 16. And it's true. If we went back here and we just added plus 3, it would give me 16 and it would prove to be correct. Does this one make sense to you?
May you repeat the AN and A1 process again?
Awesome. So let's say we do have a sequence that goes like this: 2, -2, -6, and -10. Okay. And I'd like to find the 7th term of the sequence. So what is the rule of the arithmetic sequence? The rule is supposed to be that an, the wanted term, is equal to the a1, which is the first term, plus the difference multiplied by n minus 1. I'll apply the rule right there. Okay, so what's the value of a1 in this case?
2.
2. Awesome. What's the difference? So I need to first get back here and get the difference. What's the difference then?
-4.
Yes, so any term minus the previous term would get me the difference as -4. So I'll just substitute here -4. Multiply that by what? What's the value of n? What's the wanted?
7.
So n is 7. 7 minus 1. That would be 2 plus -24, which means it would become -22. That is the 6th term. Sorry, 7th. Makes sense?
Yes, thank you.
You're most welcome. And if the sequence is not by adding or subtracting, if the sequence, on the other hand, is by multiplication or division, it would be called a geometric sequence. Now, a geometric sequence is by either multiplication or division, which means it starts with 2 and then, let's say, multiplied by 3. So it's 6 and then 18 and so on. How do I find here? It's not called difference anymore. It's actually called ratio. So to find what's happening from this term to the next term and what's happening from this term to the next term, you find something called the ratio, which is R. The ratio is mainly the term divided the previous term. So instead of subtracting term minus the previous one, that's why we call it the difference, we here actually we divide. So it's term divided the previous one. That's why we call it a ratio, because the ratio is mainly division. So let's say in this specific question, you're told to find A4. What's A4? The 4th term. What's the rule for the geometric sequence then? The geometric is an equals to a1 still, but multiplied here by r, which is the ratio, to the power of n minus 1. Still here a1 is considered the first term, and r here is, as we said, what represents the ratio, and n is what represents the position of the wanted. So if I needed A4, I'll say A1, which is 2, multiply that by the R. What's the R? I'll go back here to the side and try to find the R by putting 6 divided by 2, which is 3. Or maybe putting 18 divided by 6, which is still 3. So I'll put instead of the R 3. Now all to the power of n minus 1, which will be 4 minus 1. That would get me 2 multiplied by 3 to the power of 3. That would get me 2 multiplied by 27, which means it is 54. That is the 4th term in this sequence. Does that make sense?
Mister, I
Yes.
don't understand.
I'm sorry?
So can you explain again?
Yes, of course. So what do you understand first?
In this one?
Yes, in generally about the geometric sequence. What do you understand?
I understand
Even if it's
the
not
arithmetic sequence.
okay.
I didn't listen to the geometric sequence.
Okay. So these are the two rules that we have for the sequences. One that goes for all geometric sequences and one that goes for all arithmetic sequences. All geometric sequences mainly is a sequence that gets founded by multiplying or by division, while all arithmetic sequences actually get founded by addition or by subtraction. So if you remember in the arithmetic, if we needed to find the difference, which is the D, what would we do? We'd go for any term whatsoever, and we'd then subtract minus the previous term, اللي قبله, whatever was right before it. This is how I find the difference. And the word difference gives you a hint on what exactly to do, which is a subtraction. While here, if I need to find this R, it's not called a difference, it's called ratio. So the R is mainly ratio. Now, how do I find the ratio between any things in the world? Is actually by division. So I'll just have to now multiply any term, divide any term by the previous term. That's if I needed to find the R. Are you sure you understand how to find the difference and the ratio?
Yes.
Awesome. So if you're told that this is a geometric sequence and it starts with -2 and then multiplied by +4 and then, no, not +4, +6, +4, -8 and so on. What's the R in this case? It's this term divided the previous term. So the R is -2. I have the R. Do I have a 1?
Yes.
So I have every part of the rule. I have A1 and I have the R. Now let me know which term would you like to find. Give an example.
On -2.
Yeah, -2 is the first term. I mean, which number term, like which place would you like to find the term? Which one?
4.
4. So if I need to find A4, I just have to apply in the rule. I'll say A1, which is -2. Multiply that by the R, which we got as -2 as well, to the power of 4 minus 1. That would get me -2, and then -2 to the power of 3 will become -8, which then would give me +16. This is the fourth term of this sequence. Makes sense?
Yes.
Are you sure?
Yes.
And you can recognize the difference between the arithmetic and the geometric?
Mm-hmm.
So what if I have something like this? Now I need to find the seventh term. How can I do that?
What do you mean by seventh term? I thought like the terms you take them in the numbers you wrote.
No, I can want any term. That's why we like the rule, because the rule can get
The
me
meaning of the seventh term.
A7. Like the term number 7. Like look at the sequence. This is the first term. This is the second, and this is the third, and this is the fourth. And I'm looking to find what's the 7th. You get that?
Okay.
So if I need to find the 7th, instead of keep adding or subtracting or doing until I find the 7th, I can use the rule. That's why we like the rule. Okay?
Yes.
So how?
So to find the term R, am I gonna minus or plus the ratio and the what's called?
I first need to decide whether it's arithmetic or geometric.
I can't read it.
No, I mean I first need to decide whether it's arithmetic or geometric, right? So which do you think it is? Is it arithmetic or geometric? How would you know?
I think it's arithmetic, right?
Yes, but how would you know? Like, what would make you sure whether yes or no? What are the arithmetic sequences? They are the sequences where each term is either increasing or decreasing by the same number, yani plus or minus the same number. Is that the case in this or no?
Yes, that's the case.
Because from 3 to 8, it's what? How do I go from 3 to 8?
5.
How do I go from 3 to 5? Yes, صح. Then from 8 to 13.
I minus 3 from 8.
The other way around, actually. Any term minus the one before it, the previous term. So we take a term and we subtract the one before it from it. That would get you the correct difference, which is a difference of 5. This is the difference. So that's why we have this rule here. Term minus the previous in order to get the difference. And I can't get the difference unless I already know that it is an arithmetic sequence, right? Okay, now look at the one on the left that we started with. This one, why is it geometric, not arithmetic? Because to get from one term to the other term, you actually need to multiply by -2. So we don't add here, we multiply. And whenever we start multiplying, that's what we call a geometric sequence. So again, we just, in order to find the R, which is the ratio between each term and the other one, I'll just take any term and divide it by the previous one. So even if you took -8 and divided it by 4, it should get you the same R, which is this -2. And then substituted it into the rule to find the fourth term, which is the term number 4, which is the term right here, actually. Does that make sense?
Yes.
Are you sure?
Yes.
So it should suddenly feel like, oh, okay, I got it. That makes more. It's like it should be a time where you're like, oh, okay. Okay.
Yes.
That's awesome. Now I talked too much and you guys are already bored. So let's please go and start and solve شوية, a few questions. Now, please note this is an ACT test. It's July 2020, so that's a very recent one. If you open up P1, each form has, as usual, 5 questions. The first form is some about the parallelogram, about the average of something, about the greatest common factor, about an equation, and about probability. So let's start with these 5 and hoping that we go through them على طول quickly so that we can work on at least 2 or 3 forms ولا حاجة. Six minutes, is that enough? Is that okay for you? Okay, 6 minutes started now. P1. So number one, you're given, or you're told that this is a parallelogram actually, and you're given already that this measure of this angle is 25. You're asked to find this angle. One of the properties of a parallelogram is that its opposite side angles, are equal to each other. So this angle right here is definitely equal to this one. Also, this one is definitely equal to that one. While any angle plus the adjacent one must be equals to 180. Therefore, if I needed to just find x, I'll just put 180 minus the 25, and that side right away should give me the value of x as, I'm sorry, 155. So number one, I think, was easy. But then number two, once you actually read the question, a retail sales associate's daily commission during 1 week was $30 on Monday and Tuesday. Now my question is, does that mean 30 on Monday and 30 on Tuesday, or that means they're both all together 30?
I thought both of them is 20.
That's the thing. Each of them separately is 30. Because it's his daily commission during 1 week was 30 on Monday and Tuesday. So for those 2 days, each day he used to earn 30. So 30 on Monday, 30 on Tuesday. Then add to that another 70 on Wednesday, 70 on Thursday, and 70 on Friday. In other words, it's just 2 multiplied by the 30 because they're 2 days, and 3 multiplied by the 70 because they're 3 days. Now, if they need me to find the average of something, what's the average? The average is supposed to be the sum over the number. I'm supposed to add them all divided by their number. And he's saying already these 5 days. So I just added them here and then divide that by 5. And it should give me right away the average, which will become 54.
Yes. 270 divided by 5.
Awesome. 270?
54. Yes.
Okay. So it's 270 divided by 5, which is the 54 thing. Anyone is having any problems with this? It's fine if you're even a tiny bit confused. Or if you don't understand anything, it's fine.
It's okay, Mr.
Awesome. Now, this number 3, I think it's one of the easiest. What's the greatest common factor? So we just need a number that we can divide each of those by. So 45, 0 of course is not an answer, is not a common factor of anything. 1 is always a common factor, so let's keep that for now. And check for the others. 2. The 45 is not divisible by 2. 45 divided by 2 would come out as 22.5. So as long as there's a decimal, the 2 is not a factor. The 3 as well is not a factor of the 50, because 50 divided by 3 would not come out as an integer. The 5, 84 cannot be divided by 5 as well. So even the 5 would not work. So the only possible answer must be 1. 1 is the only number that I can divide all 3 numbers by. This is an equation, so it could go either by shift solve or by just distributing, and you'll have 2x minus 24 plus x equals to 36. And then adding the like terms together, I should have 3x minus 24 equals 36. Move the 24 to the other side, so 3x will be equals to 60, and that would give me x equals to 20. So the answer is definitely J. Any questions here?
No.
Finally, this is the one for the probability. A bag contains exactly 22 solid colored buttons, 4 red, 6 blue, 12 white. What is the probability that randomly selecting one button that is not white? So once I read the probability, I thought wanted over total right away. And I checked what's the wanted not white. How many are not white? They're the 4 and the 6. They're the blue and the red, which is a total of 10. Out of the total, which includes the white, all of them together, which is the 22. When you simplify this a bit further, dividing it by 2, it will come out as 5 over 11. So A must be the correct answer. Does that make sense?
Yes.
Yes.
Awesome. طيب, please head to P2 right away. And again, another 6 minutes for that.
It's too much.
صح? I think 4
Yes.
minutes. عشان to pressure شوية time, to be honest. برضه يعني. P2 one I think. يلا.
Okay, mister.
Good luck. Ah.
I submitted, mister.
Perfect يا حبيبي. I'm actually checking from the other device, so it's actually kind of good. ما شاء الله. I'm just waiting for 2 more. That's awesome. طيب, so just trying not to waste that much time, I'll start with Spanish. Now, what we're about to do in this question is a very important thing to do or to learn, because it kind of solves like 60% of the test or so. The idea of cross multiplying was if you understand how to use the cross multiplication wisely, you can actually solve like lots of questions in the test. And this is one of them. It says here, on a map, ½ inch represents 12 actual miles. Two towns that are 5 inches apart on this map are how many actual miles apart? So just we need to organize things. So we just need to understand that there are inches here and there are miles there, or there are map here and there is actual there, whatever you prefer to call them. The important thing is that the ½ inch is equivalent to the 12 miles. If I need to know the 5 inches is how much, so it should go under the inches here. And I need to know how much actual miles there is. So just cross multiply 5 times 12 divided by half, which would become 120, sorry, 60. Now this is one way. There's of course in this specific question an easier way to do it, because if ½ inch is 12, then the 1 inch is 24, then the 5 inches is 120. But I'm telling you this way because this way works on all questions, even if they don't even have numbers, they're just letters. So it's important to try to be consistent in this way so that it works on all different topics and you're always experienced on how to use it. Any questions here?
No.
Caden had exactly 45 plants to sell. After day 1, he sold this and this and that. So this is some sort of a sequence. In day 1, he started with 45, then they decreased, became 39, and then 36, and then 33, and so on. So apparently this is a sequence that decreases by 3. If I need to know day 6, I can either keep just counting 2 more, or I can use, if you want, the arithmetic sequence, whatever you prefer. In this case, it should be A1 plus D multiplied by the 6th minus 1. And if you calculate that on a calculator, it should get you, 30 actually is the correct answer. No. I get it now. 45, by the way, no. This has a trick in it, by the way. If you decided to use it as an arithmetic sequence, 45 would not be the first term. The first term would be actually the one in day 1, which is 42. 45 is day 0. So for us, A1 is not considered the 45. A1 is actually the 42. So that's why if you decided to use the rule, you should just use A1 as 42 and you should get the same exact answer as 27. Does that make sense, or did that way actually confuse you?
It makes sense, but like in the ACT, it will take more time. Just like
Yeah. I'm just saying the method. I'm not saying you should do it in this question. Actually, in this question, the easiest thing to do is just count, because it's just day 6. If it came in the middle of the test and it became day 16, then definitely this one would be easier.
Yes.
That's awesome. Moving on to number 8. An on-demand movie service charges $5 per month plus $2 for each movie rented. When I say 5 per month, this means that the 5 is multiplied by the number of months. When I say 2 for each movie, this means that the 2 is multiplied by the number of movies. If I say 3 per hour, then 3 times the number of hours, and so on. So the 5 is supposed to be multiplied by months, while the 2 is supposed to be multiplied by movies. So which of the following equations models the relationship between M? What's M? M is the number of movies. So I'll get back على طول before reading even the rest of the question. Since 2 is multiplied by the number of movies, then 2 must be multiplied by M. The number of movies rented per month, for a full month. And T is the total monthly cost for the service, the monthly cost. So apparently I do pay the 2M, plus at the end, because it's 1 month only, each month I pay $5. So for 1 month, I'll have to pay another 5. That would get me the total amount that I need to pay. So then when you look at the answers, H seems to be the reasonable answer. Again, the 2 is multiplied by the M because the 2 is done for each movie and M represent the movies. Does that make sense as well?
Yes, master.
Perfect. Moving on, number 9. What are the solutions to the quadratic equation above? Generally speaking, whenever I have two things that are multiplied by each other equals to 0, it's either the first one equals to 0 or the second one equals to 0. And that's exactly how the best way to actually solve this question here. Since we do have two brackets equals to each other, I can just say that the first one is either equals to 0, and I'll solve it. I'll find the value of x. Or I can say that the second one is the one that's equals to 0, and I'll still solve it, and I'll find the value of x, which will become 4/3. So now, do I have the solutions? Yes, I do. Solutions are the roots, are the x values, are the x-intercepts, which means then that C must be the correct answer. Is this one clear?
Yes.
Type. Other people would do it how? Or some people would go for actually distributing and then going to a calculator and doing mode 5-3, which would get you to the same answer. That doesn't make sense, okay? If you have the factors, remember that the factors are considered the zeros if you took them each apart and you made it equals to 0. Number 10, which is a question about the area. The first question we see about the area so far. It says an 8-inch by 6-inch rectangle. So that's a rectangle cut along a diagonal. So it's cut this way. So it became now a triangle. What's the area in square inches of each triangle? So if this is 8 and this is 6, the area of a triangle is half times base times height, which would be 24. So the answer right there is J. Any problems in this one as well?
No, master.
Okay. Let's try P3. P3, again, 5 questions. The first one is all about fractions, and I'd like you to think carefully about this one, please. Number 12 is just a stupid, easy question that could be done by a calculator. Number 13 is about sines, cosines, and tans. This one is an arithmetic sequence, and this one is about the area. So let's try to work through all 5 questions. For all 5, I'll give you 5, and if you all finished before then, I'll start before then. Good luck. In a class of 10th graders, no students participated in more than one of the following extracurricular activities. 2/3 of the class played in the band, 1/6 sang in the chorus, 1/10 played football, and 1/6 played basketball. What fraction of the class did not participate in any one of these activities? Now, we can never compare fractions to each other unless they're all from the same denominator, okay? That means that we can't say those fractions which is bigger than which, for example, unless we do have the same denominator. When you look at the fractions, they're mainly 2/3, and they're 1/6, and 1/10, and 1/60 out of the same group. So if I made them all out of 60, I can easily compare them to each other, which means if I multiplied this one by 20 here up and down, and I multiplied this one by 10 here up and down, and I multiplied that one by 6 here up and down, I should have the same denominators, which are 60. And I'll have 2 times 20, which is 40, plus 1 times 10, which is 10, plus 1 times 6, which is 6, plus 1, and that would be 57/60. If 57/60 participated in games, then how many did not? What fraction did not? It's 3/60, the remaining. 57 out of the 60, so the remaining are 3 out of the 60, which simplified should be 1/20. And this is one way to do it. There's another way, because you do have your calculators with you. All fractions are parts of a whole. So if all together are supposed to continue one complete number, or one complete fraction, that means that they are supposed to all be out of 1. So what you can do actually is go to a calculator and start subtracting 1 minus the 2/3 and the 1/6 and the 1/10 and the 1/60, and it should get you to the same answer, which is 1/20. Or you can just add all fractions just like how we did down there, 2/3 plus 1/6 plus 1/10 plus 1/60, and still, as I said, this would get you to 57/60. So you would understand that the remaining would be 3/60, which is 1/20 again. So all three methods should get you to the same answer. Whatever you remember, of course, you start with. And if these are not fractions out of a whole, if they are out of x, for example, then I can easily still change them all to the same denominator and multiply each by x. So the three methods are important because some of them would be applied in questions like those, others would be applied in similar questions with the tiny little trick of letters there. Does that make sense?
Yes.
Everyone, are we all good?
Yes, Mr.
Yes.
What's the smallest integer greater than root 61? If you do root 61 on a calculator, it will come out as 7 point something. So the smallest integer that's bigger than that is definitely 8. So H is the correct answer. If we then move to 13, 13 is all about the sines, cosines, and tans, which are the so, waka, and toa. And we just need to remember that if they say that sine something is equals to 2/3, that should be representing the opposite. And that should be representing the hypotenuse. In reality, though, the opposite of angle C is equals to 6. So in reality, if I need to know what's the value of the height, I'll just have to cross multiply. And that would be 9. So, yeah. E. Does this one make sense?
Yes.
Good. Number 14, as we said, this is an arithmetic sequence question. You're told already that it's an arithmetic sequence. So because it's arithmetic, I should be right away looking for the difference. And we said in order to get the difference, I'll just have to subtract one term minus the previous one. So it's 5 minus 1. The difference is 4. Now, since I do have the difference, and I already have the terms, the first term, which is the term 1, so I have already a1, I can get easily the form of this sequence. So I should say an is now equals to a1 plus d multiplied by n minus 1. They want the nth term, which means I should leave the n as it is. So a1, which is in this case 1, plus the difference, which is 4, multiplied by n minus 1 as it is. Distribute the 4 and you'll have 1 plus 4n minus 4. Add like terms, the 1 and the negative 4 will become negative 3. So 4n minus 3 is definitely the correct answer. Also, you can notice from the very beginning that since this is the n, and I know that in the form it's the only thing that's multiplied by n is the difference, if you recognize that the difference is 4 from the very beginning, you can tell that the only equation that would have a difference of 4 is h, because the only number multiplied by n that's equal to 4 is in h. Does that Bardo make sense?
Yes.
Yes.
Awesome. Moving on to 15, we do have a shape. Any shape that goes an irregular shape like this one, I right away think of splitting it into smaller ones. So I would recommend splitting it this way. If I do that, and actually if I need the area, but I don't need the area, I actually need the parameter. So never mind what I just said. The parameter is the sum of the outer sides. It's like building a fence for the shape. So we need to remember that these sides are also part of this fence. We know the measures of all of them, so we just need to figure out what's the measure of this and the measure of that. لو أنا عندي, so if I have this whole thing as 20, part of it is 8, then the remaining here is 12. Same thing in the other way around. If I have all of this as 20, part of it here is 14 until this point, so the remaining is 6. Now I just need to go to a calculator and add 20 plus 8 plus 6 plus 12 plus 14 and then plus 20 again. All the sides added to each other. That's 40, 60, 70, 80. So the answer is D. Does this one make sense?
Yes.
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 Are you guys okay to solve one more form, or you're tired already?
We can solve it.
Yalla, let's go for one more. So P3 then, sorry, P4, I'm sorry. P4 has something like a midpoint. It also has percentages and not just, so yeah, it has percentages, I'd say so. This one has composite functions, which is f of x and f of g of x and so on. And then it's about here mean, mode, and median. This number 20, the last one, is about rates of change or about cross multiplications somehow, but it requires a bit of thinking. 6 minutes. P4 starts now. Good luck. Sorry. Again, if I add one more number on a data that's bigger than the median, it will increase the median. If I add one more number that's smaller than the median, it will decrease it. Now, for the mean though, the mean is a different story. In order for the mean to be increased, then the new number that you add must be extremely bigger than the rest of the numbers. Yani it must be an outlier. It must be a number that's big, enormously bigger than the rest. For example, in this case, it should be something that's bigger than 100 and or 110 maybe. But if you add a number that's less than that, if you added a number that's 90 or 96 or 94 or even maybe 100, the mean may not change. It could may not increase. It could actually decrease. So the mean does not have a rule what will happen to the mean to the mean if we add a new number. But usually it would decrease if the number is similar to those, if it's in the same range of those numbers. So they're saying that this number is bigger than 90, yes, but we don't know if it's an outlier or not. We just expect maybe that the mean would either get smaller or stay the same. What do you guys think in this stage? Would the mean be bigger or would the mean be smaller or would the mean stay the same?
It's bigger. Should be bigger, yes.
It should be bigger. Why? So what did you try? What did you try it out?
Yes, I tried that. The normal mean of the 8 number is 82 something.
Okay, and then when you added a new number, what was the value that you added?
It was more than 82 something.
No, I mean, what was the new number that you added to the list?
90.
You added exactly 90, and it got bigger already, right?
Yes.
So that's the thing. The 90 itself is my test, فعلا. So 90 is the right test to test with. Because if the 90 itself would make it increase, then anything bigger than 90 as well would make it increase. If the 90 itself would make it as it is, then I'll have to think. Probably if the number is bigger than 90, it will be maybe smaller. If right bigger than 90, if it's 91 مثلا. But if the number is 100 something, it could get bigger. So the 90 itself is a good test. Since the 90 itself got me a mean that's bigger than the previous one, I can say easily that the mean will increase as well as the median as well, because the number 90 is bigger than the actual median that we have right now, which is, by the way, 81 here in the middle. Does that make sense, ya جماعة?
Yes, mister. Yes.
Number 20, they say a truck traveling at 35 miles per hour has a leaky radiator that is losing 4 fluid ounces per minute. How many miles will the truck travel before the radiator, which held 480 fluid ounces when it began to leak, is empty? So first of all, you just need to realize that there are there are rates there, and you just have to understand which are those rates or what are those rates. This is the first rate here, 35 miles per hour. That's a rate. I can actually write it down this way. I can say these are the miles and these are the hours. In 1 hour, they cover it. Sorry, yes, in 1 hour they cover a total of 35 miles. Also, there's another rate that says here there's 4 fluid ounces per minute. So there are ounces, and then there are minutes, and apparently in 1 minute we lose 4 ounces. They need to know the 480 fluid ounces would take how long first to get leaked entirely. So if the 4 ounces would be done in 1 minute, the 480 ounces would be done in how long? And I'll cross multiply. Once you do that, you'll realize it's done in 120, sorry, but 120 minutes. So when you look at this rate now, you'll find that these has no minutes, they have hours. So instead of 120 minutes, I'll switch that to 2 hours and put it under the hours, which is here. Now I'll cross multiply again, and I'll get that this should take around 70 miles for it to get entirely leaked. So even though I wasn't sure from the very beginning exactly how am I going to get that, all what I was sure of is that there are rates that I wrote down and categorized in a way where If I saw any other data that falls under the same category, I would put it there and I would be able to get any missing information. And that's how I got it here. Does this one make sense as well?
Yes, Mister.
We're all good? Okay.
Yeah.
If I may ask you, please, just to fill in the exit ticket for the day and